a journey about knowing or learning system of equations, and we had identified that system of equations with three unknowns represent planes, correct? Each equation is representing a plane. So let us consider a new set of equations, and the equation is x minus 3z is equal to minus 2. There is no variable y, which means the coefficient of y is 0. Minus 3x plus y plus 6z is equal to 3, and 2x minus 2y plus a minus 4. So I'm not giving you a known coefficient, because in this problem we want to establish some conditions for when can a set of three equations with three unknowns have unique solution, infinite solution, and no solution, because that was something that we discussed in the last video. And we gave examples of pages of a notebook meeting on the edge of the notebook, which are like planes meeting in a line, which means infinite solutions. The three planes meeting at one point, we looked at the walls and the floor or the roof meeting at a point, and we looked at two parallel planes, which could be the roof and the floor, which will not meet, so no solution. So in this problem we are looking at what are the conditions for that situation to happen. Okay, so we will rewrite this in our matrix format for our Gauss elimination method, and let me keep all the three equations ready and write down so the format is 1, 0, minus 3, because 1 is the coefficient of x, 0 is the coefficient of y, and minus 3 is the coefficient of z, and the constant is minus 2. Minus 3, 1, 6, 3, 2 minus 2, a minus 4, b minus 3. And this is the first row, this is the second row, and this is the third row. Our procedure remains the same. We try to eliminate two variables from one of the rows and one variable from a second row, and then we proceed, correct? So therefore the first place we will start with is, we'll look at, and I'm going to slightly do it faster this time because now you're familiar with it. I'm looking at R2, 3R1, this is row 1, plus R2. And what am I changing? Am I changing R2 or R1? Well, I'll change R2. Okay, so that is what I am trying to do. And I will also change, okay, let's do it one at a time. Fine, no, let's not do. So R1 remains the same. R2 will be changing now to 0, 1, minus 3. Remember, we are doing R2 plus 3R1. Okay. And minus 3. And the last row remains as it is, 2 minus 2, a minus 4, and b minus 3. Okay. We will now go to another simplification or row reduction, where we will do R3 is equal to, or R3 is changing to minus 2R1 plus R3. Okay. And now this time R1 remains the same, R2 remains the same, and R3 changes. Okay, so R3 becomes 0, minus 2. Look at a minus 4. If you want to just go back and look at it, it's R3 plus minus 2R1. So a minus 4 plus 6 will give you a plus 2. So a plus 2 and b plus 1, because b minus 3 plus 4 will be b plus 1. Okay, so that's my changes in the rows. And now we are going to, I'm not going to disturb the second row, but I will change only the third row, and I'm going to do R3 plus 2R2 because I want to get rid of this minus 2. Okay, and what I will get now is the first row remains as it is, the second row remains as it is, and the third row becomes 0, 0, A minus 4 because I'm doing R3 plus 2R2, and B minus 5. So what have I achieved by doing this? Can you realize that the third equation is one unknown? So A minus 4 times Z is equal to B minus 5. Now let's look at the condition. If A is 4, then I am having 0 times Z. Then if B is 5 also, so A is 4 and B is 5, then 0 times Z is equal to 0. Then Z can take any value. What does that mean? Infinite solutions. If Z can take any value, then when I substitute Z, Y will take any value. And if Y and Z can take any value, then X can take any value. So look at the situation, right? A is 4 and B is 5. That means 0 times Z is equal to 0. Z can take any value. However, what happens if A is 4 but B is not 5? So 0 times Z is equal to 0 is not 0. Okay, left hand side is 0 but right hand side, that's not possible. So what is the condition here? No solution, which means what will happen to the planes? The planes will be parallel. And the final one is when there are infinite solutions, right? When A is not equal to 4, then for any value of B, I will get a unique solution. Even if B is 5, I'll get Z is equal to 0, and then I'll get Y and X. When A is not 4, I will get a unique solution. So that means for these three equations, there were three conditions possible, and this will always be the case in many of the problems. You will get this kind of a situation where you are looking at. So let's substitute. If A was 4 and B is 5, let's look back at our situation and write down the problems, right? So the last equation, if you see, you will not have Z at all. So the third row, where you have eliminated X and Y variables, even if A is 4, Z will also eliminate, and the last row will become all zeros on the left hand side, and that means Z is free, so it can take any value. That's what represents infinite solutions. So this is how we understand how to work with three equations and three unknowns. Remember that infinite solution means that it can take any number of any values X, Y and Z. Unique solution is X, Y and Z can only have one value which satisfies all the three equations, and sometimes the three planes may not be meeting at all, may be parallel, and therefore there is no solution.